Hello everyone, welcome to the certification course of ANSYS Workbench by CAD-CAM-C Academy run by G2G Innovation. In the today's session, we will discuss about Introduction to Finite Element Analysis. So, the methodologies to solve engineering problems are analytical method, numerical method, and experimental method. Analytical method gives the accurate result and it is applicable to the simple problems. It gives closed form of solutions. The analytical method may mainly applicable for the analysis of beam, shaft, helical springs, and etc. Experimental method. In the experimental method, the experimental setup is required and sometimes it is very costly. It means the physical prototype is required for the analysis. The process is time consuming and the number of testings are required for the perfect solution. Then the numerical method. The numerical method is an approximate method. The mathematical representation is possible in the numerical method and we can solve the real life complex engineering problems. So the finite element analysis is a numerical method and with the help of the softwares using of finite element analysis, we can solve the complex real life engineering problem and validate the results of numerical method with the analytical or experimental method. The application of finite element analysis are which is used to solve problems involving the stress analysis, fluid flow problems, heat transfer, vibrations, electromagnetism, etc. Finite element analysis. Finite element analysis is a numerical method for solving field problems in engineering and mathematical physics. It is used for problems with complicated geometries, loadings, and material properties where analytical solution cannot be obtained. So in the figure given below, it is a cantilever beam with the lateral loading. So this problem can be solved easily by using the analytical equation and can finding out the displacement or stresses over the beam. Apart from this, the complex geometry, for this we cannot solve the problem by using the analytical method and for which the finite element analysis is used. The introduction to the finite element analysis. The finite element method is a numerical technique to solve field problems in engineering and science. The technique has very wide application and has been used on problems involving stress analysis, fluid mechanics, heat transfer, diffusion, vibrations, electrical and magnetic fields, etc. The fundamental concept involves dividing the body under study into a finite number of pieces called elements. So the division of body into the number of parts is called as discretization or meshing in the finite element analysis. So the discretization is the main part of the finite element analysis and without dividing the body into the number of elements, we cannot proceed for the analysis of any mechanical component. Particular assumptions are then made on the variation of the unknown dependent variables across each element using so-called interpolation or approximation functions. This approximated variations is quantified in terms of solution values at spatial elements location called nodes. So the figure given below is the component which is divided into the number of parts that is called as the element. The corner points of that element are called as nodes. So in the any body, by using the finite element analysis, by applying the boundary condition, that is nothing but by applying the force, there is possible for the displacement of each and every nodes and the stresses has been obtained on each and every element. The phases of FEM. So there are basically three phases of FEM, that is pre-processing, solution and post-processing. So these three phases is involved in any finite element analysis software. So what is pre-processing? The processor is a phase that processes input data to produce output. which is used as input in the subsequent phase. So the first pre-processing involves the material properties, then applying boundary conditions, then divide the body into the number of parts and generate the number of elements and nodes. So that portion is involved in the pre-processing. The second is the solution or processing. The solution phase generates element matrices, computes nodal values and derivatives, and store the result data in files. These files are further used in the subsequent phase, that is post-processor, to review and analyze the results through the graphics, display and tabular listing. So in the solution phase, any software use the differential equations at the backend to solve the unknown variables. The next is the post-processing. In the post-processing phase, there will be an interpretation of result in the form of contour plots. So in the post-processing, we will be finding out the output parameters like displacement, stresses, strains, and compare it with any other method. General steps of finite element analysis. So step number 1 is discretization, that is nothing but divide the body into the number of parts. Step number 2 is a select a displacement function or select a solution approximation. It means in the step number 2 we use the differential equation to solve the unknown variables. Step number 3 is derive the element stiffness matrix and equation. So for each and every element, the software, or we can say by using the finite element analysis, we need to prepare an element stiffness matrix. The step number 4 is the assembly of the all element matrices, that is nothing but the global or total element matrix. Step number 5 is the solve for the unknown degree of freedom, that is primary unknown. Step number 6 is solve for the element stresses and strains. And last, step number 7 is the interpretation of result in the form of contour plot, that is called as post-processing. So these are the major 7 steps of finite element analysis which is used in any finite element analysis software. So these are some basic steps of finite element analysis represented at the bottom of the slide, and these steps are followed by the ANSYS workbench. First of all, modeling, then apply material definition, then 3 is the load, 4th is the boundary condition, 5 is the meshing, 6 is solution, and 7 is post-processing. So here you can check the steps of ANSYS workbench for any type of analysis. So first is the engineering data, which is nothing but the material properties. Here we need to provide a material properties from the ANSYS library or by manually. Second is the geometry. Here we can import the geometry or we can also prepare a new geometry. Third is the model, that is nothing but meshing in the ANSYS workbench. Fifth is the setup. In the setup, we need to apply a boundary condition. The solution, this is the solution phase, that is the processing phase. In the solution phase, the ANSYS will solve the all input parameter, that is pre-processing parameters. At last, the step number 7 is the results, that in the result we can finding out the result in the form of contour plot for the displacement, stresses, strain, etc. So these are the steps by using the finite element analysis, that is by using the ANSYS workbench. The analysis has been carried out over the block. So step number 1 is to prepare that model. Step number 2 is to apply the material properties. Step number 3 is the meshing, that is divide the body into the number of parts. Step number 4 is apply boundary condition, that is to fix a face or the force is applied over the another face. Step number 5 is the solution. You can simply click on solve and solve the pre-processing parameters. And step number 6, that is last, is the post-processing. You can finding out the various output parameters like displacement, stresses, strains in the form of contour plot. So thank you very much.